hints and tips on the Friction and Forces mini lab. For each surface and for each angle, what you need to do is draw a picture first. So step one, draw your picture. Next, well, and when you draw that picture, you want to make sure you label all forces. Remember the relationship between the amount of force before it moves and force of static friction. You're actually going to have two pictures for each angle and surface. So one with Fs max, one with F kinetic. Okay, so one where you've got it just at the point where it starts to move, one where it's moving at constant velocity. Okay, once you've done that, sum of forces, X and Y. By doing the X and the Y, you'll be able to find all those other pesky little forces like gravity, normal force. You've got the force applied. There's, in cases where you have an angle with the applied force, that sum of forces on the X is going to give you the portion of your applied force that's working against friction, and the sum of forces on the Y is going to give you the portion of applied force that's working with normal force or against gravity. So you have to break out that force if it's on an angle. From there, once you've got all these pieces, you can calculate coefficients. So you've got force of static, or mu s. Coefficient of static friction is force of static friction max divided by Fn. Mu k, force of kinetic divided by Fn. So really all you have to do is find those four things. Will your normal force be different from static to kinetic? No. Normal force is dependent on the mass of the object and the angle at which the force is applied. So really all you have to find is normal force, force of static max, and force of kinetic. For any pulling that you did on a zero angle, this is ridiculously easy. So, and your normal force is going to be the same for the box, actually, for all the same angle, because normal force will change based on the angle, remember. So, but for 15-degree angle, normal force will be the same whether you're on hardwood floor or carpet. So you can keep your computations to a minimum that way. What I would do if I were doing this lab is I would make really good notes to myself, like force normal at 15 degrees. Yeah, actually that would be all I would need. So, normal force at 15-degree force application. Well, then I can use that for the hardwood floor, I can use it for the carpet, I can use it for the static, I can use it for the kinetic. So that's 4 calculations if I make myself a good note. Bookkeeping, people, bookkeeping, bookkeeping. Okay? Questions? Does that help you get started? Remember that these labs are going to be due Thursday when you walk in for your workout test, but the homework is due tomorrow. I'm also going to give you the take-home quiz due tomorrow. I'll tell you what, on the take-home quiz, I will modify how many questions you have to do on this. So I'll take it down to 4 questions, and that should help a little bit. How many were there? There were 6. Well, on a take-home, I typically give you a few more. Because it's for you, because it's practice of the kinds of problems that you're going to see on your workout test. Okay. So, my life would be easier if I didn't have to make quizzes. True. But for you, so that you get practice. So, okay. I'm just going to say this so that it's on the recording, but I'll make notes on the board for you. On the take-home quiz, you have to pick one problem on the first page pick one problem on the second page, do both problems on the last page. Okay? So you get to blow off 2 problems. But you have to do all the problems. You have to do 5 and 6. Question.
Skipping number 7 on there.
Yeah, you can skip number 7 on 4D, so if that helps a little bit, because I know some of you are pretty overloaded. Question.
Is the answers to 40?
Answers to 4D are on the website. Yes. I will, yeah. Okay, so any other general questions? I'll shut off the video.
This is where I'm cutting.